Hello everyone, welcome to the ITLS Academy. Today we are going to perform another milk adulteration experiment in which we are going to detect the adulterant, that is your urea. Okay, so what we have to do, we have to detect a urea in a milk. Simply, urea is act as a adulterant, which means that the substance which is used for the adulteration purpose. And the adulteration is what? Adulteration is adding or removing something or eliminating something that is danger for the health of the human being, then it is called a adulteration. And the substance that is used for the adulteration is called a adulterant. So here our sample is milk and the adulterant is what? It is your urea. Okay. Now the reason behind the addition of this urea is maintain the desired specific gravity of the milk and also increase its SNF value and giving the concentrated and the rich appearance. When this urea are added into a milk, it increases its SNF value. Okay, so we all know that milk have a three component: SNF, fat, and water. Now, when a SNF value increases, then obviously the price of that food that milk is decreases. Okay, because the pure cream milk are more costly than your skim milk. That's why the SNF value and the fat value are very important. Now, when SNF value increases, obviously the fat value decreases and ultimately the nutritional value of the milk also decreases. Okay. Now the second thing is that when urea are added into that milk, it give what? It give a concentrated. The milk become concentrated and also milk become what? Rich, give a rich appearance. Okay, when we see that milk, it will become more attractive. That's why this urea are added. Now the addition of urea also have a health concern, major health concern. Okay, it cause a toxicity, it cause a uremia, and it also affect the acid and base balance of the body. And this acid and base are very important for the normal body function. When it is disturbed, the normal body function are also disturbed. So that's why it is very important. So for performing this experiment, we required a 1.6% of DMAB reagent, that is called a para-dimethyl aminobenzaldehyde. Now, how we prepare it? For the preparation of this 1.6% of DMAB, we required a 1.6 gram of DMAB and dissolve it into a 100 ml of ethyl alcohol. Sorry, 90 ml of 5% of ethyl alcohol. 90%, 95 ml or 90 ml of that 5% of ethyl alcohol. Then when it is completely dissolved, we add a 10 ml of that concentrated concentrated HCl, hydrochloric acid. What we have to do? We take a 1.6 gram of DMAB and dissolve into a 90 ml of 5% of ethyl alcohol. Now, first of all, you have to prepare a 5% of ethyl alcohol, because in our laboratory we have what? We have a 100% of that ethyl alcohol. So, for the preparation of 5% of ethyl alcohol, what we have to do? We take a 5 ml of ethyl alcohol and it will be dissolved into a 95 ml of the distilled water. Now from that 100 ml of 5% of ethyl alcohol, we take a 90 ml and add into a 1.6 gram of that DMAB chemical. Then when it is completely dissolved, we add a, that is 10 ml of that concentrated HCl. Okay. Then For performing this experiment, we required the setup. We required test tube stand, micropipette tip, spatula, and dropper. The experiment is very simple. We take a 1 ml of milk sample, and into it we have to add this 1.6% of DMAB solution. If a solution turn a distinct yellow color, okay, it is a like light yellow color, but when these two are mixes and we get what we get a distinct yellow color, then it means that a urea are added into the milk. Okay, if a slight yellow color, like only a slight, only a visual yellow color, so that means that that color is due to the that natural urea. Now we have to take a sample. What we have to do, we have to take 1 ml of milk. If you take 2 ml, then you have to take a 2 ml of that DMAB solution. Now I am going to take more 1 ml. The volume of that milk sample and your DMB solution will be equal. Now, after adding this, we have to mix it properly. Now you can see that we don't get that distinct yellow color in our sample, which means that our sample are not adulterated with that urea. Okay, so this is all about the detection of urea in a milk sample. I hope you will understand, but if you have any queries related to this experiment, you are free to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms. That is your Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is your www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.